In exercise 3, we are going to be calculating concentration of the solution, and we are going to dilute that solution. So as we dilute the solution by adding water to it, we're going to calculate a new concentration and a new density. So this is pretty calculation intensive, so you just have to pay attention to what you're doing. It's just division and subtraction, but you have to know what you're doing. So the first thing you want to do is gather your supplies and then get your scale to read 0 and remove the stopper from the volumetric flask and record the mass of it. So this mass needs to be recorded in data table 8, and you're going to use this mass throughout the experiment because you want to figure out what the mass of the solution is, and you'll have to subtract this mass of the flask out because you're going to measure the solution in the flask. All right, then you're going to actually make the solution, the sugar solution. So you will cut out a small piece of paper and fold it in 4 so it's not flat. And then you're going to tear it, which means you place it on the balance and hit the tear button so it reads 0. And then you're going to add approximately 8.0 grams of sugar on the paper. So record whatever values the balance tells you, and 8.1 is fine or 7.9 is fine, just something close to 8. And you'll record that mass in data table 8, mass of sugar. All right, so then you want to dissolve the sugar. You don't want to add too much water because you don't want the water to go above the 25 milliliter mark. So add approximately 15 mils, and if you want to use your graduated cylinder to do that, you can. And swirl this. You don't want any water splashing out. So swirl this until the sugar dissolves. So getting the sugar in and dissolving it is pretty time consuming, so you need a little bit of patience while you're doing that. Once all the sugar is dissolved, then you're going to add enough water until the meniscus just rests on that 25 milliliter mark. So you'll add it dropwise and be really careful. Get your eyes right down to where that mark is so you can make sure the meniscus is resting on it. And then record the total volume in data table 8. Now you can't tell how many sig figs should be in your measurement because there's only one graduation. So that has to be given to you by the manufacturer of the volumetric flask, and it's 25.00 mils. So 4 sig figs, 25.00 mils. Then you're going to calculate the concentration, and there's lots of different ways we can express concentration, but we're going to express it as mass per volume as a percentage. So we'll take the mass of the sugar, whatever that mass was, divided by the total volume, 25.00 mils, and then we multiply this fraction by 100%. And so that is going to be the concentration of our sugar solution. And that goes right here in data table 8. It also goes in data table 9 for solution 0. So solution 0 we do not dilute, and so that concentration, the final concentration, is whatever concentration you just calculated. It's we'll just leave it. We'll leave it at that. Okay, let's go back to the instructions. Okay, so next we are going to determine the mass of this sugar solution, and the way that we do that is we'll place our volumetric flask without the lid on the scale. Make sure that the scale reads 0 before you do that, and then we'll subtract the mass of the empty volumetric flask from that mass, and that will give us the mass of the sugar solution. So that mass of the sugar solution goes right here. So solution 0 is the undiluted solution, and the mass of that solution goes right here. You'll calculate the density of that solution by taking the mass of the solution and dividing it by 25.00 milliliters. So you have to calculate the density. All right, so that's 18. Calculate the density. Now you're going to pour this concentrated sugar solution. This initial solution we'll call solution 0 into a dry, empty 100 milliliter glass beaker. Then we're going to rinse the volumetric flask really well with distilled water so there's no more sugar solution in it. And we're going to use a pipette and we'll transfer 2.5 mils of solution 0, which is in our beaker, into the volumetric flask. And again, we're going to add approximately 15 mils of distilled water to the volumetric flask, swirl it until it's thoroughly mixed. This will take a lot less time than it did to make the original solution. And then add distilled water until you get exactly to the 25 mil mark. Then you're going to weigh this. Make sure your scale reads 0, place the flask on it, and then once you get a mass, subtract the mass of the empty volumetric flask. And this is going to be the mass of solution 1. So we've just diluted solution 0, and we now have its mass. So its mass should be less than the mass of solution 0. And now you can calculate its density. Its density is going to be its mass divided by the total volume, which is 25.00 milliliters. That will be the density. So the initial concentration, the volume transferred, and the final concentration. So let's look at this. Right here, your initial concentration is the concentration of solution 0 that we diluted. So that will be whatever you have here is your final concentration for solution 0. Whatever you calculate for solution 0 goes right here. The volume transferred, that was 2.5 mils that you used, and now you've got to calculate the concentration of solution 1. And the way that you do that, here's our formula right here, C1V1 equals C2V2. C2 is your new concentration. So to calculate C2, C2 is going to be C1 multiplied by V1 divided by V2. So C1 is the concentration of solution 0, whatever concentration that was. V1 is going to be the 2.5 mils of solution 0 that you used. V2 is the diluted concentration. When you added water, your final volume was 25 mils. So you plug C1, which is what, it's not 0, I wrote 0 here, but what I meant, it's whatever concentration you calculated for solution 0. The concentration of solution 0 is C1, V1 is 2.5 mils, and then you divide that by 25 mils. Your units of milliliters will cancel out, and you will get the new concentration of solution 1. So your final concentration of solution 1 goes right here, and it should be less than that of solution 0. Okay, now we're going to pour solution 1 down the drain. And then it says repeat steps 20 through 21 for the remaining 3 dilutions using solution 0. So for solution 2, we're going to take 4.5 mils of solution 0. We will place it in our rinsed out volumetric flask. We'll add 15 mils of distilled water to dissolve our 4.5 milliliters. Then we'll add enough water to get to the 25 milliliter mark. Then we'll make sure our scale reads 0. We'll place the volumetric flask containing the solution on the scale, subtract the mass of the dry volumetric flask from the mass, and now when we do that, we'll have the mass of solution 2. And we can calculate the density of solution 2 by taking its mass divided by 25 milliliters. The initial concentration is all going to be the same here. The initial concentration will always be whatever you calculated your concentration of solution 0 to be. So this will all be solution 0. The volume transferred is going to be 2.5, 4.5, 6, and what else? through 3.0 and 6. So those are going to be the volume transferred. And then to calculate the final concentration, you just plug into this equation. So for this equation, when you're calculating C2, C1 is always the concentration of solution 0. V2 is always 25 milliliters. The only thing that's going to change is how much of solution 0 you use. So for solution 1, we use 2.5 milliliters. For solution 2, we use 4.5. For solution 3, we use 3. And for solution 4, we use 6 milliliters. So this equation, the only thing you're changing is the volume of solution 0 that you use. And then the final thing you're going to do is graph the relationship between concentration and density for the sugar solution. So go over here to graph 1, and let's see. So what they want you to do is they want you to, whoops,